So this is the part fourth, and this is the last part. We will discuss about the interpolation with the help of geostatistical methods. So let's begin with the first point, that is what is geostatistics, and second, how it is important to us. So what is geostatistics is, as you can see, geo plus statistics on the surface of the earth, and it is related to any phenomena. Phenomena may be natural and it may be cultural also, and it may be a combination of these two. Natural phenomena may be rainfall, may be the temperature. As you can understand, that temperature and rainfall, especially the temperature, or maybe it may be elevation, it does not change drastically. It changes little. So there is a kind of statistics we can apply on the surface of the earth. For instance, if you will see Meghale to Adigrat, Adigrat to Adwa, and then Adwa to Aksum. So there is a distance which is involved. It is not like that Meghale is very close to Adigrat, then Adigrat and Adwa is very far. No, there is some spatial significance among these human settlements. So that is the statistics we will talk and we will understand. And this is really very important. Now I'm coming to the second point. Why this is important to us? Because this is our subject. Because we are studying the surface of the earth. All the phenomena, we should know the statistics. And under the geostatistics, we can say that it will help us for our study, for our analysis, for our research work, and for our geographical understanding. I will use this software and this data, which means it is very interesting to know that how it is related to the surface of the earth or the statistics of the earth, and how it is different from the method which we have learned earlier. So for that very purpose, I will use the same data, and as you can see here, that under Geostatistical Wizard, this is the geostatistical part and this is the Kriging part. By the way, geostatistical method are very means earlier it was Kriging only, but thereafter there are some methods arised. So Kriging, we can say that geostatistical is Kriging only, Kriging or co-Kriging. So if I opt this option, I choose this option, Kriging, and I take my data with the temperature, and when I move on here and again move on, then I will see that here this is X and Y. This time it is covariance. Let me change it to semi-variogram. You can see here this semi-variogram. And about this semi-variogram, I have already talked about in my video tutorial number 2. So in this semi-variogram, this x-axis uh, shows the distance and y-axis shows the value. Now to explain it more, I will move I will move on to my second video, which I have already talked about, like semi-variogram. So in semi-variogram, you will see the this is the cloud of the points, and here I have to give the attribute like temperature. So when you will see the temperature here, you will find this is all these points are the points which we can call the empirical semi-variogram. So this x-axis is a distance and y-axis is the semi-variogram values. So important thing is here, if these are the lags here, If I change these legs to maybe 8, then you can see here these 8 legs uh, are here, the first, second, third, fourth, fifth, sixth, seventh, eighth. And one thing is important to understand. In the first leg, the this is the very nearest values here. Okay, the first leg you will see here, this is 0.36, so it is around 36 kilometer. Yeah, so this value may be maybe 10 kilometer something, but if I take this point here, it will be uh, close to 36, this point here. Okay, so as you can see this leg here, and if I measure this leg here, you can see this is around 34, means it is not exactly at 36, it may be 34. So if I choose all these legs within this distance here, then you can see it is covering the whole, all the points, because all the points have its neighbor within 36 kilometer. All the points are being taken, and the software is calculating the empirical semi-variogram. So the calculation of semi-variogram will help us to understand the relation, the significance. So if semi-variogram is less, means it is more related, means we have got a significant distance. But as semi-variogram increases, we are getting less information. Then we will find a point where the semi-variogram has got flattened, like this. One thing. So one thing you should know, that how these points are generated, which I have already discussed in my video number 2. Uh, and the second, another important thing is, if this is the leg of 36 kilometer, then what about this point here? So if I choose this point here, so this point does not mean that from 0.36 to 0.7. No, it is from 0 to up to this distance. Let me take this point here. So it will be 72 kilometer. Okay, this is 70, around 72 kilometer, this one. So these are the values here. In this leg, it will show all these points which are from 0 to 72. Let me take this point here. So as you can see that this point here, in this point we can see here, this is close to 40 kilometer. So there is a head and there is a tail. So this is the square difference in between head and tail divided by 2. That will give us the value of semi-variogram. So in geostatistics, such type of, the x-axis distance values were not given in deterministic method of interpolation, but in the geostatistical analysis, we get this x-axis, and this x-axis shows us the distance. So this I was talking about the semi-variogram. What about covariance? If I take the covariance, and covariance, you will see that covariance is very much identical to correlation. And in this case, it may be here negative relation and it may be the positive relation. So positive relations are important to us. And when the value of covariance is higher, means it is more related. And we will find those points or that distance where we are getting some significant relationship. So this is about semi-variogram. and this is about the covariance here. Now let's move to here. One thing is you can reduce or you can increase or decrease the leg size. It is very tricky to know that how we should identify the leg size. So in some of the literature it is written that if you are taking the nearest neighbor analysis tool, or if you are performing nearest neighbor analysis, then it will give you some leg size or nearest neighbor distance that is observed. So that we will discuss later. Now I'm moving back to the geostatistical wizard here. This is our geostatistical wizard, and this is the Kriging here. And Kriging is what? It is an interpolator that can be exact or smooth. It is depending on the measurement error model here. So let's take our point here, and we will take our data, that is temperature, and we will move on. And these are the Kriging types here: ordinary Kriging, simple Kriging, universal Kriging, indicator, and this is ordinary Kriging, simple. So and these are the output surface. We'll discuss one by one about all these Kriging type and output surface types. So when we will interact with the geostatistical wizard, we will see that there are different types of Kriging available for interpolation. So the question is why there are different types of Kriging. Uh, then you have to think 2 points. The first point is you may have different types of data. Your data may be normally distributed, may not be normally distributed. Your data may have a trend, or it may not have a trend. So you have different types of data, and different types of data, you know, the there are different types of Kriging suitable. So the first thing is you have different types of data. The second thing is the different types of Krigings have different assumptions. So you have to see your data and you have to see the Kriging types. Thereafter, you have to choose the correct Kriging types. And finally, when you will get the result, you have to see the validation results where the error is less. So we will discuss one by one with the help of software. So we have the software open, and the data which we will use is the same data, the point data. And within this point data, there is the temperature data here, which we will use in our interpolation. We will choose geostatistical analyst and geostatistical wizard. And as you can see here, the Kriging. So Kriging and co-Kriging. Basically, Kriging, if we are using only one attribute, then it is a Kriging. If we are using two attribute or more than two attribute, then it will be co-Kriging here. So just now I'm using only one attribute of my point data, that is the temperature here. Then as we can understand that this Kriging, it can be exact or it can be smoothed, means it depends on the measurement error model. Okay, so let's move on next. Then first we will see the Kriging type. Here there are different Kriging type: ordinary, simple, universal, indicator, probability, and disjunctive. So all these Kriging types are suitable for different types of data, which we have already discussed. So first I will take the ordinary, and we can choose the surface types also. Here this is prediction, quantile, and probability, and prediction standard error. So here I want my surface of prediction, means prediction in the unknown areas based on the known points. So this time I'm not going for transformation type. I'm not going for order of trend removal. So My Kriging type is ordinary Kriging. I can finish it here now, and it will give me a report. So what is the report? All these points which are given in the reports are important to understand. Dataset, as we know, the data set is my data set is location is here, type is feature class, field is temperature, and total records are 666. It is not a problem. And method is also not a problem because you know I have used the ordinary Kriging and output type is prediction. So the point of understanding here is that what uh, I have not gone through the trend type here, and the searching neighborhood is also not much difficult because we have already discussed in video number 3, but here also I will discuss in little uh, what is the searching neighborhood. The important point to understand here will be the variogram, semi-variogram. What is the lag number of why this lag size and nugget are important, and what is the model type that we will discuss. So here if we move, this is ordinary Kriging. Data type I have already taken, attribute I have already taken, and my surface type will be the prediction. Then I will move to the next here. So as we can see here, the semi-variogram model is given. So as you can see here, the Geostatistical Wizard Kriging step 3 to 5, and at present we are step 3 of 5. So step 3 is showing us this semi-variogram model here. So this blue line is showing the model, and these are the bend, and these the plus sign in blue color is showing the average of each leg. So the average value of each leg is given in the plus sign, which is in blue form. And as you will see here, this is x-axis, which is showing us the distance, and y-axis is showing us the semi-variogram scale. And as you will move towards right side here, in general, you know, the variable is semi-variogram. And the good thing with this 10 ArcGIS 10 version, that we can optimize our model. Then what is the significance to optimize the model? Means our error will be reduced to the least if we will optimize our model. So we will see it in later. So as you can see here, this semi-variogram, and you know, this semi-variogram modeling is very important, which is the base for Kriging. So it is must to understand everything related to semi-variogram, or there is another that is covariance. So what is this semi-variogram and covariance model, and how does it help in our interpolation? So for that very purpose, you see this model here. This is x-axis, which is showing us the distance, and the y-axis is showing us the semi-variogram values. If you will see the structure of this graph, you can see it here, and here it can help you like okay, let's see this one here, and let's see here. So as you can see, the x-axis is the distance here, and the y-axis is the semi-variogram. And the semi-variogram and covariance, both the functions quantify the assumption that the things which are nearby tend to be more similar than the things which are apart. So as the distance is increasing, the graph is also going up, moving up. So the moving up of the graph means the semi-variogram at the semi-variogram scale means as the semi-variogram value will increase means the dissimilarity will be there. So when the graph reaches the highest means when this graph reaches the highest means if you will see it is reaching highest up to here. So this this is important to us means this is this part is important to us here when yeah maybe up to here maybe up to here maybe up to here it will calculate it will be calculated by the software. So it is very very important to understand that where uh, where the graph reaches to the highest thereafter it is flat means where it reaches the highest means this zone is important to us for our interpolation. So this distance is important for us. So this distance is known as range. Where the graph reaches highest is the sill, and from where this means from the semi-variogram, that is we can call it the nugget here. So what will be the value of nugget? It will also affect the results here. So this is the partial sill. The complete sill is this, and this is the partial sill. So as you can see here, as you can see here, okay, as you can see here, what is the nugget value here? Nugget may be up and down. It is up to your hand. It is under your control. But you can optimize the model and it will take a suitable nugget for this model. And what is the major range? Major range in this case is 6345. What is the partial sill here? In this case, this is the partial sill here. It is very small this time, around 0.2. Sorry, partial sill is 2 point. Okay, because here you can see you have to rescale as per this value. So partial sill is means if we will see here at this scale value it is around 0.2 here. Okay, because here it is a 2.07, here it will be 0.207, 0.207 here. Okay, because this is the rescaling factor here given. Similarly, distance is also given here, and leg size is here given, and the major range is 6345. So major range in this case is here, around here, this one. So from here the model is getting flat here. So at this time this model is taking your values, but you can optimize the model. And when you will click this one to optimize your model, and another important thing to understand is it is showing search direction and it is taking all the direction. But sometimes what happens, your data has some directional effect, maybe like temperature. As you are moving from north to south, the temperature is decreasing or increasing. So north to south, you can search your direction in maybe at 90-degree. So it will, or if it is east to west, then you can search in that way. So you can see here uh, if you want to give your search direction this time, this is the search direction here, and you can change your direction. As you are changing your direction, you see the model is also changing. Okay, so where you get means optimized model as per your data, because in this case here I am not taking the direction, but you can choose the direction also. And if you are choosing the direction means at the correct time, means by looking your data, then it will give you better results. So here I'm not going for direction choosing this time. You can explore this one, uh, means what will be the effect of direction. You can see the results also, so it will help you to understand that whether choosing the direction is helpful for you or not. If error is less, maybe it is helpful for you. So all this is about the cell range, partial cell, the distance, nugget, and leg size, and number of legs which you can minimize or maximize also. Here you can, if you want to minimize, it will minimize. So now it is you have given 8 legs here, like 1 2 3 4 5 6 7 8, 8 legs. And you can increase the legs also here. It will give you 1 2 3 4 5 6 7 8 9 10. So this is all about this step third, and thereafter you can move on. Okay, before, let's see this model here. And when you will move on, as we have seen that this is our surface which will be generated, and this surface is generated based on this search criteria. The neighborhood type is a standard, you can change also. And how many means maximum neighbors, minimum neighbors, and sector type. So here the four sectors are given. If you are you can choose without offset also, like this. But here it is better to see the means see the neighbors in all directions. I mean, if I take this one here, okay, you can, what you can do is you can increase the size also, like if you want, you can make it maybe 12 here, you can make it 12 here, you can make it 12 here, like this. So when you are giving some the angle factor and major axis and minor axis, if it is equal, your anastrophe factor will be 1. If it will be changed, then this factor will also be changed here. Okay, so you can practice it for by giving different types of the search neighborhood. Thereafter, you can see here, for this point, for this very point, for this very point here, how many neighbors are being taken? 12 neighbors are being taken. And as you will move from this point to away from this point, the closest values, closest point will have more weight. You see 50% weight is given to, I think, this point. Thereafter 23% weight is given to this point, and here the point value is coming like this. So let's move to next here. And now we got our validation result, and there were 5 steps, and all 5 steps are over here. And this is the most important part, the validation. You have done everything, and now this is the validation result. Now you have to decide whether this model is okay or not. So in the validation part, you are getting the number of samples, the mean, root mean square, and another things you are getting. So to explain this part, I search some valid research because I found here uh, this paper. This paper is on the optimal selection of you see this paper is how means interpolation methods, and in this paper I found I have downloaded this paper, and they have given very good explanation of the how we can validate our result and what is the significance. So I'm coming to the validation part here. So in this paper, I will attach to your mail this paper also, because this is very important paper. They have talked about the geostatistical methods also, the Kriging estimators, how it is estimating, what are these values here. So this lambda function is, it is giving you the Kriging weight here. This is the Kriging weight, okay? Weight may up, weight may down also. And this, the n here, this is the total number, and this is the one value, and how it differs from the mean. So this is the Kriging estimator, and the next is semi-variogram and variogram here, as we have already discussed. This variable data 1 means this may be head and tail. There are 2 points, and there is a difference of these 2 points, and they are dividing by 2. So this is the function of semi-variogram, and we were talking about ordinary Kriging here. In ordinary Kriging means the most important consideration in ordinary Kriging is what is the assumption that the mean value remains constant over the whole area to be interpolated. So means another is mean is unknown here, okay? The mean is unknown, but if you will see the simple Kriging, the mean is known here in the function of simple Kriging. The mean is, it is taking the constant mean and constant mean, but here the mean is unknown in ordinary Kriging. So I'm coming to the validation part. They have uh, talk about the validation methods. So cross validation, as you can see here, cross validation, the last one is very important to decide whether our model is acceptable or not. So for this, there are some thing which the performance of a spatial interpolation method is affected by several factors, such as the sampling density and distribution and data variation. Therefore, the performance must be carefully evaluated in each case. The cross-validation method is a statistical method to assess the accuracy of the interpolation. Very important point. Accuracy of the interpolation. In cross-validation, each measured point is sequentially omitted. Omitted. This is very, very important point. Okay. Very important point. Let me explain it. This one. In cross-validation, each measured point is sequentially omitted, and the value is predicted by using rest of the data. Okay, how it is done? How it is done? Let's see. Let's see this one. How they come to know that this is the first point. The measured is 30. This one. Let's see. Let me export this table. let's see, give the name like practice here. Okay, this is by practice here. Now we can see. So the first point is measured value is 32 and predicted is 33. 32, 33. This is here 32, 33. So how they do means what software do is here. So at this point, this is measured is 31 and predicted is also 31. So error is very less error. But if I will see this one here, it may have more error. Why? Because the surrounding points are less in this point. So the error will be higher. Okay, measured is 32 and predicted is 31. So what is the idea here? Idea is very clear. Yeah, in cross validation, each measure point is sequentially omitted and the value is predicted by using the rest of the data. Means if they have to predict the expected value, this is measured value, and if they have to predict the expected value, then what they will do? They will remove this data. They will remove this data. Okay, and based on these data and based on this model which we are using, they will predict here the value. So they will predict the value here, and actual it is 32, but what they predicted based on rest of the value, that here the value should be 31.72. So how much error we found? This is the error here. Okay, so that we have to see that error should not be more, because in the same way the error will be in the unknown areas also. So let's see another points which are important to us, like total number of samples are 6. What is the mean error here? The mean error is predicted value minus measured value divided by total numbers, mean error. So as you can see here, this is predicted value minus measured value, and this is the error here. Okay, predicted value is little higher, so this is in positive 0.5. If predicted value is like less than 29.16 minus 30.14, so the error will be in minus here. So all this because this is very important word here. If you will see this one, okay, all this is the error. This is the mean error. So whatever error is here, when you will take, when you can see the statistics here, then the mean is, okay, the mean is here, error predicted minus 0.026. So this is the same here, mean minus 0.026. This is the mean error, okay, mean error. The next point is mean absolute error may not be given here, but this is the way they do the mean absolute error. It is, I think, the more or less same. Mean error and mean absolute error is almost the same. Okay, mean square error. Here what they have done, the difference is they have made the square, this one. So mean square error, this positive and negative sign will be, means negative sign will be removed, because if minus values will be there, it will change to the positive value. So one important thing is, if mean square error is more, the important point it is given here that it measures the magnitude of the error weighted on the square of the, therefore it is very sensitive to the outliers towards minus side or positive side. So if outliers are more, then your mean square error will be higher in this case. So it is sensitive, very sensitive to the outlier. Like if this is minus something minus 2, then 2 times 2 is equal to 4, then 4 is the higher value. So in the outliers, it is very sensitive to the outliers. What is this? And the next is, which is, I think, is the very important point, that is the root mean square standardized error. By looking this value, we can decide that whether we should accept this model or not. And here they have mentioned that RMSE should be close to 1. If it is more than 1, it means general uh, general underestimation in the variability of the prediction. If RMMSE is smaller than 1, what does it mean? That it is a general overestimation in the variability. So we are overestimating the variability if it is smaller than 1. And if it is greater than 1, we are underestimating the variability of the predictions. So this is very important, root mean squared standardized error. This is the standardized error we are talking here. So here in this case, this is 1.5. It should be close to 1. If it is 1.2, 1.3, 1.5 is okay for this. So let's see what is this here, statistics. Okay, standardized error, average standard error, average standard error. So here we are getting this average standardized error, average standard error. This is 1.5. Yeah, and standardized error is minus 0.01. So it is very close to 1, and yeah, it is very close to 1, and it is not means much skewed to one direction. So this is the way we can see our validation, our result. And when you are doing any work, if you are making interpolation, so you have to give all these values in your the method which you used, and what are the prediction errors uh, in your data analysis. So you have to give all these values in your work. Okay, so once you think, okay, this is fine now, I will go for it. And the now the very important point is coming. You can see, and you can see, and you can note all these values at a place here. And thereafter I'm coming to that point that you can optimize to your model. You can optimize your model. So to optimize your model, you have to click this button, very important button. So when you will click this, do you want to proceed? Yes. Okay. Now you see it has changed your nugget. It has changed your cell. It has changed your cell. It has changed your partial cell. It has changed your major range. Now it is far, means it is 30. Major range is changed. Okay. So now see the values here. And these values you can compare with your previous values. Okay, mean is this now, and your root mean square standardized, that is 1 here, and average standardized error, you can see here this average standardized error. Earlier it was 1.5, now it is 1.3. So it has reduced, and your model has been optimized better than before. So this is the function which you can use, and this is very nice function given in 10.12345 ArcGIS versions. Okay, so this is all summary. You can note, like when you will finish, all this summary is here. You can copy and paste somewhere. You can save this one, this summary, because this summary you have to use in your work. Thereafter you can finish it. You will finish it. And these are the predicted values. If you want to see the errors, you can see the errors. This is the line and how it is, and you can see the standardized error also. With the help of normal QQ plot also you can understand. Your maximum values should be at this point here, means, and back. Okay, so you have already done it. You have to optimized it also. And now we are moving to this, and I will finish it. Okay, and this is our result here. The good thing is that if you think that there is some thing which is not giving you a satisfactory result, so what you can do, you can go to this model. You do not need to go again and again from the scratch. So this is ordinary here. What you have done is you have optimized it before, and suppose if you are interested to change some kind of the cell, partial cell, like this is 3.7, you want to make it 2.5, like this, then your model is changed here, then just finish it. Okay, a little change will be there in your results, in your surface. So okay, here this is ordinary, and here this is 2.5, which I changed, but okay, again 3.7. Okay, make it finish. Okay, do it. Here 1 2 3 4 5 6 7 8 9 10. 10 classes are given. If you want to make more classes, you can give more classes here. Maybe you can give 20 classes, 20 classes, then you will get more variation in your data. Let's make it 10 only. 10 classes. Okay, another important thing which is important in this part is we are making the surface prediction type of surface. Okay, but another very important surface types are here, like quantile. Okay, and if you are giving the quantile here any value, if you are giving 0.5, then your output map will be produced with the prediction of the median values at each unsampled location. Okay, and if I give 0.75 here, 0.75 here, then what will happen? Your output map will be produced where there is a 75% chance that an unknown value lie below the surface. Okay, means if I'm giving 0.75, means 75% chance that an unknown value lies below the surface, means the lower than the values, and 25% chance that the unknown values lies above the surface. So let's see it 75, 0.75 here, and make it finish. Okay, then this is the quantile map. Okay, the next is probability. When you create the probability surface, and if you are giving any threshold values, as you can see, the minimum temperature is 18 and the maximum is 36. Your interest is 27 degree. Okay, 27 degree. Okay, so if you are giving the 27 degree, then what it will do, it will divide your surface, created surface, into two category: below 27 and above 27, with some kind of probability. So do it next, make it finish here. Okay, so the blue part here, this blue part, okay, this is blue part, very high probability is there that this is not exceeding the 27%, sorry, 27 degrees Celsius. High probability, not more than 27 degrees Celsius. But this red part shows high probability, Even this if I take this part here, okay, this black now changed to black color means very high, 100% probability that this region the temperature is more than 27 degrees centigrade. So if you are doing your research and if you have the pollution data, then you can make the probability maps by giving some threshold value, that if what is the probability that here the temperature or the pollution level may be above this value. So this is probability map is very very important for maybe if you are doing some related to any pollution related to maybe the soil pollution, maybe the air pollution, and maybe the another type of pollutions, or if you are doing some temperature, or if you are doing work on rainfall and another things. So this is the way how you can create the surface. Let's see method properties here. Then this will be the prediction standard error. So as we are using ordinary prediction standard error, it will give us an idea that which part of the Tigray the error in the prediction error is less and where error is more. Let's make it finish and do it okay, and you can see the result here. So while you are following the ordinary Kriging, you will find that this area the error is very very less, but as you are moving towards darker side, the error is getting higher here. Why? What is the reason why the error is getting higher around this area? Because all these points are having less neighborhood. So for prediction, this area does not have more points, but on the other hand, if you will see prediction here, this area here is having more points. This area is having more points, so error is very less in this area. So it will help you to understand that which part of the map is having the highest error. Okay, so this was all about the ordinary Kriging, and let's see the prediction map. Okay, all these things you can go through one by one. Okay, this is the prediction map, and this was about the ordinary Kriging. Next, we will see the simple Kriging type. So now we will talk about another method of geostatistical analysis. I will open the wizard, geostatistical wizard, go to Kriging. Thereafter, I will choose the my points, and here I will take the temperature, and I will move on. And this is now, before we were talking about the ordinary Kriging. So in ordinary Kriging, there may be 5 steps, but in simple Kriging, if you will go through the simple Kriging, the steps will increase. Number of the steps will be the 6 steps here. So you have to observe, you have to see the difference in the process when you are going through the Kriging types. So more or less the things are same except some assumption. And if you will see the difference in between ordinary and simple Kriging, you can see here it is mentioned that in the ordinary and simple Kriging, this is the function given for simple Kriging here, and in this function this mean value is involved here, and here they will take the mean value of the measured data. So this is, and in ordinary Kriging which we were doing before, here mean is an unknown trained constant. So this is the difference. So in ordinary kriging is more flexible than the simple kriging here. And in simple kriging, there is a major control of the mean value of the measured data. So let's see uh, the simple kriging here. Transformation type, decluster type, order of trend removal. I'm not going through it, but when you will go to next, you will see something more here. Okay. You can see the density of your data here in the form of the frequency graph, or you can see in cumulative form, or you can see in normal QQ plot form. So how your data is spread, and thereafter you can go to the next, and when you will see, this one is the same which we have already discussed before. You can optimize the model, and this time this is covariance. Earlier I was here also you can take the semi-variogram. Okay, so uh, this is the nugget here. Nugget is given 0.20, 0.20. Partial cell major range is around 159 kilometer here. That is 159 means up to here, and partial cell is 0.8. If you will see from here to here, you will find 0.8. Leg size is this, number of legs is this, and you can optimize your model. So let's optimize it. When you will optimize it, the software will minimize the standardized error, so your results will be better, and it will change the values. Do you want to proceed? Yes, I want to proceed. Now it has optimized your values, and now let's move on. The next, here I'm not giving the search any particular search direction, but if your data is affected from directions, like if there is a effect north to south effect, or east to west effect, or some northeast to south west effect, or northwest to southeast effect, then that direction you can give here. Then I will go to the next. Then you can see your search criteria, which you can change as per your need here. Here this is it is taking the best way, like 45-degree offset, and thereafter you can move on, and here this is your result. So with the help of this simple kriging, you can correlate it with your previous work that was done by ordinary kriging. Here number of cases are 666 samples are here. The mean error is minus 0.08. So the mean error is 0.08 here minus, and RMS is 1. Root mean square 1.4, and mean standardized error is this, root mean standardized is this, and average standard error is this 1.53. So it is more or less same, like 1.53 and 1.41. So both the if you have to give more insight, then you can export the table as before, and let's do it. We will finish it, then do it. Okay, we have got a surface here. This is by the simple kriging, and this is ordinary kriging here, and you can compare. your results here. Okay, so visualization is of course very important, and when you are visualizing your data, it means classification is more important. Than you can see here what values are given here and what values are given here. 23 I think. Okay, so you can see the visualization from both the methods. And the when we talk about the surface types, it's very important. It's a predictive surface with simple Kriging type, but you can choose the quantile also here. The probability is a very good function. You can give any threshold value, like if this is 27, here you can see the temperature values. And if you are interested to see uh, maybe 30 degrees centigrade temperature, where there is more than 30 degrees centigrade temperature with some kind of the confidence or some kind of then make it finish here. Okay, do it. So this is exceed means there is 0% probability that here the temperature is exceeding more than 30 degrees centigrade. But here there is some kind of probability is there that here maybe temperature may be above 30 degrees centigrade. But in this case, if you will see the last one, this color here, you are 100% or 97 to 100% sure that the temperature will not be less than 30 degree, or you can say that we are 97 to 100% sure that temperature is exceeding 37 degree in this area. So this was about the ordinary Kriging. Sorry, this was about the simple Kriging here. If you will see, let's make it the prediction surface. Similarly, you can practice on universal Kriging, and when you will see the universal Kriging here, you can see universal Kriging is also known as Kriging with the trend. Okay, here trend is very important. So Kriging with an external drift and regression. It is a multivariate extension of ordinary Kriging. And instead of constant trend uh, average, it uses a linear or higher deterministic trend function. Okay, a local trend function would be given. So here, what is the local trend in your data? It will give more emphasis on the local trend function. So let's try this universal Kriging here next, and here it will see this is the second part here, and here you can see the trend is coming, and you can optimize your model. Okay, and thereafter you can move on. Here advanced search properties are given, then do it next. This is your model. Here also you can optimize your model, and thereafter when you will go to next, and here you can uh, give your neighborhood criteria. You can change to maximum, minimum, or search type. You can change the major semi-axis, the minor semi-axis. So if you will make it false, then you can change it. Okay, if this is true, you cannot change. So make it next here, and you can compare with your data validation with your another methods of interpolation. Here mean is 0.0077. It has reduced, means this model is giving you the surface with very less error. So here average standard error, okay, average standard error has come down to 0.96, which is of course very close to 1. So with the help of this model you have got a better result, and you can export it here, because exporting is very important for mapping purpose. This is the predicted, this is cross validation by universal method. Save it and it will come to your map. Then you can see this one, covariance here. So these are the error. You can see the mean of the error is 0.0077, here 0.0077. Standard error is 0.96. Average standard error is 0.96 here. Okay, this is very important to, it should be close to 1 here, and standardized error is 0.01. This is mean standardized error 0.01. Okay, so this is the way you can observe, or you can give more insight to your results. And thereafter let's see, we can make it finish. So if we compare these three methods, like ordinary, simple or universal, so we are getting better from the universal type of Kriging. And thereafter, you know, the important thing is you can make it finish, you can make it okay. So here you have got this one, and this is by ordinary Kriging, this is universal Kriging. So there you will find a little change, and you have to see the values and measured and predictive errors, and thereafter you have to decide that which model or which technique is giving you better results, and you can choose that one, and you can put that result and the analysis criteria in your results. So as you can see that we got this surface, and let's see, the we use the universal Kriging type, and the surface type is prediction. And if we move another Kriging type, that is the indicator, you know, the indicator is the type of Kriging uh, which uses a threshold value. So as you can see here, minimum temperature is 18 and maximum is 36. And if you are interested for some kind of you know, the analysis, you want to know that the area or the places where the temperature is less than or more than a value. So if I take here, this is 27.5, I can choose any value like 29 degree, then 29 degree will get a probability here. And another things are we can modify, like, then okay, all these are the semi-variogram. Here also we can optimize the values. Next, then finish it. Next, all these are the values. in here, then finish it. Okay, so as you can see here, uh, this is the these are the points, and this is the cabellage of Tigray region. So I gave 27, and I was interested for the exceeding, okay, where temperature is exceeding of 27 degree. So the blue color is showing here 0% probability that here temperature is exceeding above 27 degrees Celsius. But as you can see here, the probability means the boundaries. You see this slope. So as you will move from lower to higher, means right from lower than 27 to higher than 27, then of course the values does not change drastic immediate, but there is some kind of maybe the probability. And as you move from lower to higher, and this red color, if I change it to another color, then we can say that this green color is showing that here the probability is 98 to 100% that the temperature is exceeding or more than 27 degrees Celsius. So this is the temperature value. You can use any value if you have the pollution, maybe air pollution, water pollution, soil pollution, or some another kind of the data you have. So that data you can use to to make a prediction layer with probability. As you know, we have already talked about the indicator. So after indicator, if you will see this probability, it is also more or less similar like indicator. You have to give some threshold value, and you will find the area where where this temperature is above 27.5 or whatever value you want to give. You can give from here also, from the standard distribution. So just you have to change your cursor, and you will find it, the value will be change it here. Okay, threshold values. Okay, then okay, this is also disjunctive. This is also having the here the approximation method is changing here, that is multiplicative skewing. So there are another methods also which you can use for smoothing or approximation, and thereafter there is some you can optimize your model also, and you can do it like that. So the important one which you can use for your study are three: ordinary, simple, universal, and universal. And if you are interested for looking some values using threshold, then you can use indicator and probability. So this was all about the Kriging, and I hope you will practice it well. I will attach the data to you, and as well as the paper which I have used to explain some important terms or concepts. So thank you very much for listening and watching. Thank you.